Hi, welcome back. Now we're going to talk about the paddle. The paddle is the thing that we want to draw on the screen under the user's control. We want the user to be able to move it right and left. And then eventually we want the ball to be able to hit the paddle and then bounce off of it. And that would be a successful move by the user. In other words, the user places the paddle in the path of the ball. So we've got a couple more variables here. We've got a couple of floats here, paddle X and paddle Y. These are the X and Y position of the paddle. And then we also have, we want to be able to trap a touch event on this canvas, on this view. And so we also want to be able to reposition the paddle. So I've declared a couple of floats here, the old X, which is the old touch X position, and the old paddle X position. And we'll see how I use those in a moment. Now, before we draw anything else, or before we draw, we need to know the size of the paddle. P size X is 1/2 the width of the paddle, and P size Y is 1/2 the height of the paddle. So I'm just declaring these for now at least as finals. I don't want to change them. They're constants. So when we want to set up the actual paddle X and Y, we want to do that here in our constructor. The problem with using this get width and this get height is that both get width and get height within the constructor are returning 0 at this point. The background view has not yet been returned. So I can't use get width and get height at this point. But there is a way, a device independent way, to get the screen metrics, and we do it by declaring a variable called display here of type display, and this is get context, get window manager, get default display, and this will return the display in a device independent way. Now I have to cast this, because of Android, into an activity. Then I can get a new point and get the size into that point, and then the width and height of the display are size.x and size.y. Now I can position my paddle 3/4 of the way down the screen, and that's very simple to do. Paddle Y is going to be the height divided by 4 times 3, or if you prefer, the height times 3 over 4, and then the paddle X is going to be the width over 2. So that is positioning, initially positioning the paddle. Drawing the paddle is trivial. We're going to do it in onDraw the same way we draw the ball. So we're going to draw the paddle, and it's just going to be drawing direct as paddle X minus P size X, paddle Y minus P size Y, paddle X plus P size X, paddle Y plus P size Y, and we'll use the same paint, white solid fill. All right, so we're getting there. Now, the last thing we have to deal with is how do we move the paddle. So we're going to override a method of a view class called onTouchEvent. And in order to get the down, we could return true or false from this event. But in order to get any other motion event type or action type, we must return true. So the first rule here is return true. In fact, even if you return the result of passing this through to its superclass, it doesn't always return true. It only returns true on motion event action down. So we must return the hard-coded value of true. Otherwise, action move won't work. So what are we doing? We want to get the current touch point. So touch X is event.getX, and touch Y is event.getY. Now, we only also want to process if the touch is below the Y position of the paddle. So otherwise, we're not going to do anything at all. So if touch Y is greater than paddle Y, now we want to get the event action type. So if that type is action down, we're going to register old X as event get X, or touch X we could have said, and then old paddle X as the current position of the paddle. However, if this is an action of a move type, we want to move the paddle by the same amount as the difference between the old touch position and the new touch position in the x-coordinate. But we don't want to let it go more than halfway off the screen on either side. So we're getting a value called delta, which is old x minus touch x, and then the new paddle x position is the old paddle x minus the delta. Now, now we need to filter to see if it's off the screen on either side. So if new paddle x is less than 0, we want to say new paddle x is half the width of paddle x. And otherwise, if new paddle x is greater than the width of the screen, here we do have this get width, so we can use it, then new paddle x is equal to this get width minus the paddle size x. Otherwise, paddle x, we're good, we're in between someplace. Otherwise, paddle x is new paddle x. So this is how we display and move the paddle and handle its current position in OnDraw every time we redraw the canvas. So let's go ahead and look at the app as it's running. Now remember, the ball is not going to, at this point, have any kind of interaction at all with the paddle. Here we're just testing to see if the paddle moves. So here we are, the ball's moving, we already knew that. And let's see if we can move the paddle. Well, I've got a touchdown, now I'm moving, and pretty good. Now, of course, there's no collision yet, but let's see if I can move it off the screen. Nope, not by more than half. And on the other side, let's see. Nope, we're good there too. So it looks pretty good. And of course, this won't happen in the real game. So there we are. We're able to display and move the paddle. And every time OnDraw happens, it checks to see where the current paddle X is. Now, we've got paddle Y clamped to 3/4 of the way down the screen. So that's why we're not able to move up and down, which is a good thing, probably. Thank you very much.